In this lecture, we want to learn the relation between the angular velocities of two links between which the motion is transmitted. The purpose is to estimate the angular velocity of the follower link as a function of the angular velocity of the driver link. For that, we compute the ratio of the two angular velocities. I mean the ratio of the angular velocity of the follower link to the angular velocity of the driver link. We will need this as a key formula to solve the problems of this section. Let's go back to the example of direct contact. In order to relate the angular velocities of link 2 and link 3, we need the intersection of the line of transmission and the line of centers. So let's draw them first. The line of transmission passes through the contact point and should be along the normal direction of the two surfaces. And the line of centers connects the centers and we extend to intersect the line of transmission. This is the intersection point of the line of transmission and the line of centers. We name it as Q. Let's assume link 3 is the driver and rotates counterclockwise at an angular velocity of omega 3. This rotational motion is then transmitted to the follower link and makes it rotate at an angular velocity of omega 2. What the relation says is that the ratio of the angular velocity of the follower to the angular velocity of the driver, meaning omega 2 over omega 3, is equal to O3Q over O2Q, which means the ratio of the distance between the rotation center of the follower link and point Q to the distance between the rotation center of the driver link and point Q. Notice that we have the angular velocity of link 2 here and the center of link 2 here. And similarly, the angular velocity of link 3 here and the center of link 3 here. The angular velocities and the centers are at opposite sides. Regarding the directions of the angular velocities of the driver and the follower, if point Q is at one side of the two rotation centers, then the angular velocities have the same direction, which, as you see, is the case in this example. Sometimes it might happen that point Q is somewhere between the two centers. In that case, the angular velocities of the driver and the follower will be at the opposite directions. That's it. We just need to learn and use this formula to solve the motion transmission problems. If you are interested to see how we can prove this formulation, watch the next lecture. Otherwise, you can just skip it without losing anything and jump to the lecture after.